This is probably your idea of what an atom looks like, with a nucleus of protons and neutrons at the center and electrons spinning around the nucleus. But the scale of this model is not right, not even close. Let's say that this sphere is the electron field, where their outer orbit is, and let's say it's over 200 feet in diameter, as big as this 22-story building. Even at this scale, the small electrons orbiting at the edge of the sphere would barely be visible, and the nucleus of a simple atom at the center, say, on the 11th floor, would be the size of a grain of sand. And there is literally nothing in the space between the nucleus at the center and the electron orbit. So, pretty much the entirety of every atom is nothing. Now, let's look at that grain of sand again. There is somewhere around 600 quadrillion atoms in one grain of sand. That's 600 followed by 15 zeros. If an atom were as big as a grain of sand would be 1 cubic mile in size, to hold 600 quadrillion grain of sand-sized atoms. So, with each grain of sand representing an atom, the cube would be more than 4 times as tall as the Empire State Building. Now, let's go the other way in scale. I'm pretty sure you already know that this popular model of the solar system is not to the actual scale. And, again, it's not even close. This time, let's imagine that the Earth is the size of that grain of sand. And the Moon, then, would be around 1/4 the diameter. And the Sun would be about 4 inches in diameter, about the size of a large orange. Seeing their relative size to each other looks like this, with most of the Sun out of the picture, and the Earth and Moon in the top right corner. Now, let's see their relative distances from each other at a realistic scale. If the Earth was the size of the grain of sand and was put at the end of a yardstick, pretty small, the true scale distance to the Moon would be at about 1 inch. And the Sun, as we said, would be the size of a large orange. So, where would the Sun, the orange, be on the 3-foot yardstick? Well, you'll need to have 11 of them, because the orange will need to be 33 feet from the grain of sand, or about the length of this school bus to represent the distance between the grain of sand Earth and the orange the Sun. Now, how far do you think Neptune, the outermost planet in our solar system, would be from the orange-sized Sun? By the way, compared to the Sun, Neptune would be about the size of that BB pellet there at the right. Well, it will need to be more than 1,000 feet from the orange, as Neptune is almost 3 billion miles from the Sun. Here you see 3 football fields, end to end, and our school bus, parked there at the left goal line of the left field. See it? So with the grain of sand, Earth, at the front end of the bus, and the Moon just 1 inch to the right, and the orange at the rear of the bus, Neptune, the BB pellet, would be in the right end zone of the rightmost field, or, as we said, more than 1,000 feet past the orange. Beyond Neptune is the Kuiper Belt. This is the region that contains dwarf planets like Pluto, comets, and other icy bodies, and it goes out another 2 billion miles past Neptune, or over 4.5 billion miles from the Sun. So, using the orange to represent the Sun, if it was placed at ground level at the One World Trade Center building, the edge of the Kuiper Belt would reach to the top of the spire. That's about 1,800 feet from the orange, the Sun, at ground level. The point at which the solar system ends and interstellar space begins is hard to define. The solar wind, the Sun's discharge of electrical particles that creates the Sun's electromagnetic field in the aurora borealis on Earth, goes out about 11 billion miles from the Sun. This bubble around the Sun is called the heliosphere, and that would be more than a mile from our orange-sized Sun. Voyager 1 was launched by NASA on September 5, 1977, to study our solar system and interstellar space. That was 47 years ago, and it is moving very, very fast, around 38,000 miles per hour. At that speed, a trip from Los Angeles to New York City would take less than 4 minutes. On May 24, 1990, when it was about 4 billion miles from Earth, Voyager 1 turned its camera to face the Earth one last time. It took this iconic photo, showing the Earth as a tiny speck in the vastness of space. It was astronomer Carl Sagan that termed it the pale blue dot. In the summer of 2012, at around 12 billion miles from Earth, Voyager 1 passed beyond the heliosphere and became the first interstellar spacecraft. As of May 2024, Voyager 1 has traveled 15 billion miles. Now, where can we go from here? How far is it to the next nearest star? Well, that would be Proxima Centauri, and it's over 4 light-years away. You already know that a light-year is the distance that light travels in 1 year, and that distance is an incredible 6 trillion miles. So Proxima Centauri, the closest star to our Sun, is more than 24 trillion miles away. If we could send Voyager 1 to go check out Proxima Centauri, well, we would have to wait a long time. Traveling at 38,000 miles per hour, it would take 74,000 years. Now, instead of a grain of sand representing the Earth, let's make it represent the Sun. At this scale, Proxima Centauri would be 18 miles from our grain of sand-sized Sun. So, imagine this sandy shoreline, and our Sun is 1 grain of sand on the close end of this beach. And Proxima Centauri is a grain of sand at the far end of this beach, way at the top of this photo, 18 miles away. And that's the closest star to our Sun. Now, let's go further. Besides our Sun and Proxima Centauri, there are an estimated 200 billion other stars in the Milky Way galaxy. And most of those, like our Sun and Proxima Centauri, are many trillions of miles from their nearest neighbor star. And it's estimated that the Milky Way galaxy is around 100,000 light-years across. Let's look back at that true scale distance of the Moon from Earth. It shows that the Moon, pictured at the center, is 240,000 miles from Earth. Now, let's pretend we have another moon, about 1 3/4 times away from Earth than our real moon. It's shown at the right, at 424,000 miles from Earth. If we imagine a grain of sand, somewhere here on Earth, and that it represents a star at one end of our galaxy, the Milky Way, and imagine another grain of sand, somewhere on that far second moon, 424,000 miles from Earth, and that grain of sand represents a star at the other end of the galaxy. That is how vast our galaxy is. Hundreds of billions of stars, with trillions of miles of space between most. Okay, the next level to go is to the next nearest galaxy. That would be the Andromeda Galaxy. It is 2.5 million light-years away. That's an unimaginable 145 billion trillion miles away. I don't even know if there is a name for a number that big. So how many galaxies are there in the universe? It's believed that there are over 100 billion, and recent estimates suggest that there may be as many as 2 trillion. Atomic particles and atoms themselves are unimaginably small, and the universe unimaginably vast. The scale of distance of everything is pretty amazing.